on, guys? Welcome back. Today we are doing the Hack the Box Academy SQL Injection Fundamentals. So this box is actually, this module we'll do in different parts. So don't worry, I'm still going to continue the other modules I have going. I'm almost done with the last one. That's why I'm doing this one. So let's go ahead and hop into it. First and foremost, hit that like button, hit that sub button. It helps out tremendously, and it allows me to keep getting more awareness out there, because I actually think Hack the Box should let me do most of their academy stuff, and currently I'm not allowed to. So the more subs we have, the more kind of we can negotiate and try and do that. But let's go ahead and hop into it. So the intro to databases. So before we learn SQL injections, it says we need to learn more about databases and structured query language, which is true. So which databases will perform the necessary queries? So databases use SQL in this case to actually communicate, and that's how you query the server and get information back, right? So web applications utilize backend databases to store various content. So that's true. So usually you would have a web application, and then you have a backend database over here, and the web application will query the database, and then it will return a response, and that's where the SQL language comes in. Okay. So this can be core web application assets like images and files on a web server, content like posts and updates, or user data like usernames and passwords. And you usually will see the username and passwords stored this way. And the main reason is because the username and passwords are stored somewhere else inside the network or behind a firewall, and then the web application is presented to you. So there are many different types of databases, each with its particular type of use. Traditionally, an application used file database, which was very slow. So that was just a file, just files stored. It's very slow, right? So, which was very slow with the increase in size. So as it got really large, it just kind of became pointless because it takes so long. So that led to database management systems, DBMSs. And you can see database management systems help create, define, host, and manage databases. Basically what that means is it's a system that does it all for you and makes it easy for the user. That is necessary because otherwise you're really having to get in the weeds with some of the technical capabilities and create your own queries and all of that stuff. DBMSs can actually do the queries for you if need be. Okay, various kinds of DBMSs were designed over time, such as file-based relational databases, NoSQL, graph-based, and key value stored. Okay, so there are multiple ways to interact with the database, such as command line tools. So you can actually use command line. You can use graphical interfaces. So if you don't have command line experience, you can actually just click around and interact that way, and APIs where you can actually make calls. So database management systems is used in banking, finance. It's used everywhere. Let's just say that. Some of the essential features are concurrency. So what this allows it to do is real-world applications have multiple users. This is common. Let's say you're logging in for the day, and you log into the same site every day, and you're logging in at 7 a.m. and so does everybody else. Well, if the database didn't have a concurrency feature, it would just allow one person to log in at a time, and that would really hinder things, right? These concurrent logins can actually log in multiple different times at the same time, multiple different sessions at the same time, right? Without losing any data or corrupting anything. Consistency. So with so many concurrent interactions, like we just said, if you have 1,000 employees and they're all logging in at the same day or at the same time, right? The database management system needs to ensure that the data remains consistent and valid. So what that means is, imagine, for instance, you have 10 users all logged on the same database, whether it's with an application, reaching out, whatever, and they're making changes. Well, that web application or whatever needs to be updated in real time from the database without maybe saving 10 different changes that override each other. It has to know what to do. So it actually makes sure that that data is accurate and consistent and doesn't allow it to be corrupted and make those mistakes. So now security. Database management systems provide fine-grained security controls that through user authentication and permissions. So it just adds a security layer to it, prevents unauthorized viewing. It allows you to probably edit permissions and things like that as well with granularity, but doing it from the GUI, which is much nicer for the user. Reliability. It is easy to back up data and rolls them back. Yep, that's pretty common. Databases allow you to just roll back if need be, and that makes it very handy in case something happens or there's any issues, or maybe you do an upgrade and it crashes, whatever. Now, structured query language makes it very easy for the user to interact with the database. So here's how it looks. Here's how it works. You have user, you have a tier 1, you have tier 2, and you have the DBMS, okay? So the user goes to log into inlanefreight.com, the client application, right? And then that client application will reach out to the application server, okay, because that's what is hosting that website. So when they go to inlanefreight.com, that application server is hosting inlanefreight.com, so they're actually going there. And then it will reach out to the database management system and validate any of the information, whether it's images and all that stuff. So then it actually displays that stuff on top of that website. So the second layer is middleware, as they call it. It's the server which interprets these events and puts them in a form required by the database management system. So what that means is it actually will allow it to be, let's say you click on an image and you need to pull that image. The application server handles that request to the database management system in a way that makes sense to the database management system. So hopefully you guys are tracking. Hopefully that makes sense. And then obviously you see the users and the database admins come in internally here so that they can actually administer it. The database management system usually would be inside a DMZ or inside the network, and the application server would be externally hosted. It is possible to host them on the same host if you wanted to, but as they scale, you're going to want to have them on their own. Okay, let's go ahead and go to the next one. Okay, now we have types of databases. There's two types, right? There's relational, I said rational, and non-relational, okay? So only relational databases utilize SQL, while non-relational databases utilize various methods of communication. Okay, so what does that mean? So a relational database is the most common type of database. This is what you're used to seeing when you see MySQL and things like that. It uses a schema, a template to dictate the data structure. So what it does is it uses, like it says, a schema, tables, columns, rows. It puts everything in relationship to other things. So if I have a user and then a password, they are in a relationship to each other, and the tables can actually relationally connect to each other. So if I have a table over here on, let's say, table name is usernames, and then there's a table passwords, I can have a identifier on it, and I can identify that user 1 is linked to password 1, right? I can have them in two different tables, and they can also be linked, right? So you can query them, and they are related to each other. So tables in a relational database are associated with keys. Like I said, identifier, that's what the key is, that will provide a quick database summary or access to the specific row or column. So here's what I'm talking about. So here you have the ID is 1, 2, 3, whatever, and that links to, that's related to the admin test SA, admin test super, admin test admin, right? And then you have posts. So the posts, you can see, they actually use this user ID to clarify. So if you look at the posts table, it's actually pulling data from the users table and linking it, okay? So you see the user ID is 2. It's going to be the test account here. That's what it's doing. And then this ID is actually the ID of the post, right? So it's a way to have the tables relate to each other and be relational in the sense that they can actually link to each other. And you can see the relationship between tables within a database is called a schema. So if you have two completely separate instances where you're not going to have anything related to each other, no usernames and passwords connected and all that stuff, you would have a separate schema, okay? So you would have your schema, then you'd have your table, then you'd have your columns, then you have your rows. And these are columns, by the way: ID, user ID, date, content. Rows are 1, 2, 3, the rows. Columns are vertical, rows are horizontal. So now non-relational databases are a little bit different. These are called NoSQL database for short. Does not use tables, rows, columns, or prime keys. So the prime keys and things like that, I don't know if it's going to dive that deep into it. If it does, we'll talk about it. But these non-relational databases, they don't have schemas. Instead, a NoSQL database stores data using various storage methods. So there's multiple ways they can do it. Looks like JSON's one of them, XML. All of these are things that you've probably seen before. You've seen XML files, you've seen JSON files most likely, but they are just a way of formatting the data where you can see that they have just random posts here, but they do have a key and they do have a value, so you could actually reference the key and get the value, but there is no reference to each other. There is no relation to them really here. So you can see this one has 1001, 1002. So if I wanted to pull the content, I could reference 100002, right? So there you go. Pretty easy, pretty self-explanatory. Usually I will say these are very good if you're doing something smaller. I don't see a ton, and maybe you guys have seen a ton, but I have not seen a ton of non-relational databases that carry a ton of data, and usually it's for obvious reasons, but they do have databases that have different method for injection known as NoSQL injections versus SQL injections, which we're covering here. All right, let's go ahead and talk about it. So now, intro to MySQL. So MySQL is just the language here that we're talking about. The module introduces SQL injection through MySQL, and it's crucial to learn more about MySQL. So we need to know about the structured query language. So SQL syntax can differ from one relational database management system to another. However, they are all required to follow the standard. So why is that? Because if you work on database over here and then you have a product that you purchase over here, they should be able to talk to each other. They should be able to work together. So there has to be a standard, and that is the standard there. So we'll be following the MySQL Maria database syntax for the examples shown below. So you can see here, command line. If we wanted to manage it, command line, right off the bat, we just have MySQL. We have a username, root, and then password, and then it'll say enter the password, right? So this is just a snippet, but you would then type the password. Now, if you wanted to, you could say MySQL tac root and then P and then actually type the password, but this is more common practice because then it doesn't show on the command. It just asks you for it. All right. And then you can see the syntax is a little different. There should be no space here in between the two. So the examples above, let me make sure before we get too crazy that there's no lab. Okay, there is a lab. So let's go ahead and start that up before we get going. All right. So now, as we go through, you can see we logged in there. Now we have MySQL username root, and then we have hdocker.hackthebox.eu. So we're actually, if you see, when we do not specify a host, it will default to the local host. We don't want that. We want to connect to something. Here we're connecting to the docker.hackthebox.eu on port 3306, and then we're going to type the password. So what we're doing is we're saying we're connecting to a remote database, right? We don't want to connect to a local database. We want to connect to one that's sitting somewhere else, which in this case is on the Docker container. Okay, so now creating a database. So we create it when we're in MySQL, right? Once we're logged into the database, we create database users. Okay, and this semicolon is always going to be the syntax that stops that command, and it knows that that's the end of the command. Now you can see when we go to show databases, we actually get the one that says users right here. There's nothing in it right now, but we can say use users. Once we say use users, and you can see SQL statements are not case sensitive. That's important to note. You don't have to use. It's just a lot of people that have used SQL for a while probably you'll see older guys using the capitals, but you don't have to in this case. So it is good practice to specify statements in uppercase to avoid confusion, right? So now we have tables, so we can actually create a table if we wanted to, and we could say create table logins. That's the table, right? But then we have to specify the fields that we're going to put in there, the rows, right? Or the columns, excuse me. So in this case, we're going to put ID, and we're going to tell it what kind of character we need in there, right? It has to have what type of data is going to be in there. In this case, it's going to be an integer in the column. The username is variable characters, right? And then it's 100 is the username. Okay, so it can be up to 100 characters long, which is very long. Password is characters, but it's going to be up to 100 characters. And then date of joining. So that's going to be the date time. So when they actually create this, that's going to be the date time in there, right? So that's just telling it what type of data is going to go in there. There's still no data in there yet, but that's telling it what type. Okay. So now we say create table, logins. And then here we go. This is what it looks like. ID integer, username variable, blah, 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 blah. And then you have to close it out. You have to say, okay, I'm done, right? SQL queries above create a table named logins with 4 columns. Yep, 4 columns. The first column, ID, is an integer. So you can see show tables. You have the logins here, but there's nothing in it. So when they describe logins, look, there's nothing in it. It's just going to tell you that the ID requires an integer, these require characters, and this requires date time, right? There's nothing there that any data in there yet. So now within the create table query, so within this right here, create table query, there are many properties that can be set. We talked about that. So one of them is integer, right? That's going to be your integer, a number, right? Now in this case, they're saying ID integer cannot be null, and it's going to auto increment, meaning it's going to start at 1, go 2, go 3, go 4, go 5, go 6, 7, 8, 9. So that's how you get that primary key. Now, the not null constraint ensures that a particular column is never left empty, i.e. requires a field. We can also use the unique constraint. So you can say here for variable characters, unique and can't be null. So what that means is pretty simple. It just means that the username has to be unique, so they can't have the same username as someone else, and it cannot be nothing. Okay. So now another important keyword is the default keyword, which is used to specify the default value. For example, within date of joining, we can set the default to now. So the default, that means if we don't specify a specific time, it will default to now, right? Which returns the current date and time. Now, the primary ID or primary key is ID here. What that means is any place else we want to actually reference this, whatever, whether it's the name, the password, whatever, the primary key is the identifier, which is that auto increment, the 1, 2, 3, 4, 5, 6, whatever, right? The reason you do that is because when you reference it later, or if you ever reference it in some other database, or some other table, you need to have something that is the primary key that will always identify it. Because the username could change 100 times, but that primary key is not going to change, right? Okay, the final create table query will be as follows. So create table, logins, ID, integer, not null. We want to auto increment, right? We want the username characters, unique, not null, meaning we want the same, or we don't want it to be used again. We want it to be different username every time. Then not null here, we're saying we need a password and it has to be 100 characters. So if you did 101 characters, it's not going to take it, right? And then date of joining, we want that now. And then we want the primary key to be the ID. So this ID, this 1, 2, 3, 4, 5, 6, 7, whatever, will be the primary key that we can reference later. Okay, so now let's say connect to the database using the MySQL client for the command line, using the show database command to list the database. What is the name of the first database? Okay, so right off the bat, pretty easy stuff. If I could find for some reason my mouse is not here. Let's full screen it just because I can't get my mouse to work there. Okay, so for some reason my mouse wouldn't work. So all we have to do is go up here and look at it. It'll tell you, if you just follow exactly what they said, we're going to say MySQL, and then we're going to use the username and password, and then the port and the TAC H for the host, right? So connect to the database. So it looks like the root user is root and the password is password, and then there's the port. So what we're going to do is we're going to say MySQL, right? TAC user, root, and then TAC P, but we want to leave the TAC P for now. So we're going to say TAC H, and then we need the IP address, which is 83, okay, didn't work. 83.251, and then we got to tell it which port, and we do that with a capital P, and we say 39469, 39469, right? And then we say TAC P for password. Now when we connect, it's going to say enter password, and was it capital P for password? Just password, okay. Password. So now, welcome to the Maria Database Monitor. Commands end with colon or /G. Keep in mind you have to use those those semicolons, and we'll show you here. So what we're trying to do is name the first database. So we need to say show databases, but you see they have the semicolon in there. If you don't have that semicolon, for instance, if you were to where were they running some commands here? Like right here, if you didn't have that, it would just keep asking for more queries. It would never end. It would, you could exit it, but it never ends until you do it. So now we say show databases, right? And we have to put that semicolon there. And you have an error in your SQL syntax. Okay, what did we do wrong here? And you can see it says show databases. Okay, so maybe it's because I spelled databases wrong. That's probably why, right? Show databases, and then we have to hit that semicolon like I said. Otherwise, it will just ask for another command. And you'll sit there and you'll just keep giving it a command, giving it a command, giving it a command. And you can see the first one is employees. So we say, hey, employees. Perfect. Okay, so we've got the first, we've connected, and we're good to go. So now we have SQL statements. So SQL statements are, what are we going to do with this? We know how to create a table. We know how to do that, but how do we put data into the table? How do we take data out of the table? That type of stuff. So now what we're going to say is the insert statement is the first one, because this is the one you're going to see when you're creating a database. Insert into table name. So in this case, employees. I don't know why that went so small, but yeah. So insert into table name. The values we're going to insert is column 1, column 2, column 3. So those ID, the whatever. And keep in mind, you can make those whatever you want. So here, in the case that we used before, the logins, you can see they have to have the identifier, the name, the password, and then the date. And you notice they actually inserted the date versus allowing it to default. The other thing to keep in mind is when you're doing commands, right, you have to have the proper amount of columns. If you're just trying to do it with the improper amount of columns, it will not work. It won't understand what to do. So you can see here, however, we can skip filling columns with default values such as ID and the date. We can skip those ones because this can be done by specifying the column names. So what we do is we say insert into table name, column 2, column 3, and then values, column 2 value and column 3 value. Okay, skipping columns with not null constraints will result in an error. So you can't just skip it entirely. You have to have something, right? And you can see columns 2 and 3 would be admin password. So we say, hey, admin password, boom, boom. And if they don't have a default, then it doesn't know what to do. So, okay, so now here's the actual syntax. Insert into logins, username, password, values, admin, password, right? And then it will automatically assign it an ID and a date. Yeah, you should definitely hash it before storing. Never store a password in clear text like that, because if someone does have access to the system, they're just gonna go ahead and look at that and select or use the select statement, get it, and boom, there you go. They got your password. So insert into logins, username, password, values, John, Tom, whatever, right? See how they can just keep adding. So if you had an entire list of username and passwords, maybe you sync once a day, whatever, you could have this going and you could just keep doing it, right? Separated by columns or by commas there. Now the select statement, this is one that you're going to see when you're using SQL injection. A lot of times you're wanting to get information from the database, not necessarily put data into it at this time anyway. But you can say, now that we have inserted data into the tables, let's see how to retrieve the selected data. So we say select everything from table name. Well, in our case, employees would be the table name I'm worried about, right? So we'd say select everything from the employees table, and it would print out the entire table to me. Now, that's why this select everything, that's why that asterisk is a wildcard. So it says select everything. The from keyword is used to denote the table to select it from. It is possible to select from specific columns, right? So you can say select column 1, column 2. I only want to see ID and username from the table name employees here or logins here. And you can see if you do everything, you get ID, username, password, date of joining. Here, if you just did the username and password fields, you get username, password, right? We just asked for the username, password. We don't care about the ID or the date of joining in this case, right? Now, if you want to get rid of a table, delete it, you drop the table, logins, and then you can say show tables and look, boom, it's gone. It's that easy. Now, alter the table. So this is to, instead of insert data or drop data, delete data, you want to alter something that's already there. So you just say alter table logins, right? Because the table itself is logins in this, or employees in that case. We want to add a new column, int capitals, right? We want to add a new column called integer. Or int, I shouldn't say integer because I don't know what if that's what they were wanting, but to rename a column, we can use rename. So add alter table logins. We want to rename column, new column to old column, right? So the new column is going to be named whatever. So here we say alter table logins, modify, and then in this case, we're going to modify the old column date, right? And what it is we're modifying the type of information in there. All right, so finally we can drop a column using drop. So alter table, logins, drop, old column, right? Okay, so now we're going to do an update statement. While alter is used to change a table's properties, the update statement can be used to update specific records, okay? So the alter will change the table's properties, like how many columns there are, how many rows there are, what is required in those columns and rows, but the update will change the actual data inside. So here we're going to say we want to update table name, in this case logins. We want to set column 1, we want a new value. Column 2, we want a new value, and then we could say where condition. Now this is where the primary key comes in, because we could say where ID equals 1. So we could say we want to set, and we could say username, and we could change the username to John, right? And password to John, where ID equals 4. And then Tom would change to John, right? So here we're saying update, logins, set, and you can see set, password, and we're going to equals change password where ID is greater than 1. So you can see all the IDs that are greater than 1 is 2, 3, 4, and they change their password to change password, right? So to query above updated all passwords and all records where the ID is more significant than 1. So again, where it's more significant than 1, and you may have identifiers that are different than 1 through 10 or whatever, but let's close this and try to open full screen again, see if it actually opens full screen. Okay, it did. Perfect. Or I think it did. Okay. What is the department number for the development department? Okay, so department number. And my mouse is gone again. Let's see if we can type. Not sure what's going on with this box here. Can we type? No, we can't type. All right. Can we get this thing to work here? Hopefully this attack box works for us. Come on, baby. If we have to reset it, we will. Okay, I'm not sure what's going on with it, but we'll reset it. And what we're going to do here is, oh, there's a note here. We have to specify the where clause with update. So with update, in order to specify which records get updated, the where clause will be discussed next. Okay, so they're saying they added this where clause and they haven't talked about it yet. So they're going to talk about that that where clause here in a sec. But what it's saying is where this condition matches, which is this condition is ID is greater than 1. So now looks like the next one is what is the department number for the development department? But we have to connect again to the I don't know why it's doing this, why we're having such a tough time. Maybe I should just stay in here. Let's just try and stay in here. I don't know what's going on with this. This is having a really tough time rendering in. All right, hopefully we get it working, and there we go. Okay, we got something going here. Okay, we're just gonna stay right here. We're not gonna do anything else because it's working right now, right? So we're gonna say MySQL, tac u, root. We're gonna hope that that's typing. MySQL, tac u, root. Okay, and then it's root and password. Okay, tac u root, and then we're going to say from here, we're going to, okay, we got a little something happening. 83.136.253.251, and then we're going to say capital P 39469, and then lowercase p for password. Come on, baby. This thing's struggling. We hit enter. Enter password, and it's just password. Okay, we're in. We're in. Now we can say show databases. Hit enter, and we're right back to where we were. Now, was the department number for the development department? I'm not actually sure if. Well, I'm not sure if I'm even typing right now, honestly. Oh, okay. So there we go. Okay, so this froze again, so that's great. There we go. I think we're good. So we can say show. Maybe we can say show. Do. All right. So hopefully this works, but we're gonna say select. Okay, it did actually kind of work. Select everything from employees, and we're hoping that that's the correct database. All right, don't worry. We'll get there. We'll get there. Hacking's never been fast, right? I typed it. Now I'm just not sure if it's actually working. Okay. Select everything from employees. We'll see if that worked. We'll see what it prints out. And I'm not even sure what it's asking us. No database selected. Oh, I didn't select the database, which is... No, I did select the database. What the heck? Unless I spelled it wrong again, which wouldn't surprise me. Yeah, I literally selected it from the database. So select from employees. Okay, so select everything from employees. Maybe you guys see, maybe I misspelled something. There, I did. Let's see. Come on. No database selected. Interesting. What am I missing here? Oh, I'm not selecting the database. That's why. So we'll say use employees. I was looking at the tables, not the actual databases. Okay, so now we can say, well, now we gotta actually see. Select everything. Man, it is tough typing on this thing, I'll tell you that. So let's just see if we can select everything. And see how right there I didn't put the semicolon, so it asked me for the next thing. So show tables. If you don't put that semicolon, it will not work. So show tables. There's our tables. Now we have, what is the department number for the development department? Department number for the development department. Well, let's just say show everything from departments. That should do it. I didn't put a semicolon like I said. Come on. This box is tough to work with, I gotta be honest with you. Okay, you have syntax to use. Check the manual that corresponds to your, okay. What do we have syntax issue wise? So we have, looks like select. Oh, I said show. That's what this box has got me going all over the place. That's what it is. Select everything from departments. All right. This box is so hard to use. Okay, and then it's asking us, what's the department number for the development department? D005. Ah. All right, there we go. That's a good stopping point, I think, mainly because this box is not working and it's very hard to type. So hopefully this helped you guys. Hopefully we can keep going, and we'll finish this one as well along with the file transfer one. So hopefully you guys have a great day, and hopefully this helps you guys in some way. Thanks. Yo, what's going on, guys? Welcome back. Today we are doing query results in the SQL injection fundamentals. So we're going on part 2 now of the SQL injection fundamentals, and we're going to actually kind of get a little bit more in depth with how we use SQL, and then we're going to actually do our first SQL injection. So pretty exciting stuff. We're going to get all the way to probably jump our intro to SQL injections, and then we'll take a break, come back part 3 to do the rest, because those are a little bit more complex. I want more time to explain them to you. So before we get started, hit that like button, hit the sub button. It helps out a ton. It's the only way I can grow, so I really, really appreciate it. All right, so first things first. In this section, we're going to learn how to control the results of an output, which is true. This is important because some databases have millions and millions of entries, so you need to be able to control the actual output, right? So what we're going to do is here they're showing how to order them or sort them, right? So you can sort the results of any query by order by. So you can see select everything from logins. So they're going to get every login, and they're going to order it by password. So you notice now the password is in alphabetical order. So now the password column is in alphabetical order, but you notice the IDs are out of order, 2314, not 1234, right? Because it changes based on the password column. So that's one way to do it. And you can see by default the sorting is done in ascending order, meaning alphabetically A to Z. You can change it from descending from Z to A, right? So that's one thing to make sure you know. And you can see to change that, all they did was order by password, descending, and the command. It's also possible to sort by multiple columns to have a secondary sort. So you can see select everything from logins, order by password. So again, we're by password, but there's 3 people with the same password. So if 3 people have the same password, we want to set a secondary, which in this case is ID. So now it will actually put them in ascending order based on the secondary because they have the same value for the passwords. So what that means is if they have the same value here, it's going to revert to this ID and put them in order that way. All right. So now limit results. This is something we might do if, for instance, we know in this case the logins, the first user is going to be an admin. We would probably say give us just the couple first results because we want the admin, right? So we'd say select everything from logins, and then we limit it to 2. So we only want 2 entries, 1, 2, right? That's something that you're going to probably use a decent amount if you are looking at thousands or millions of results. Okay, let's see what else. So now we have, if we want to limit results with an offset, we could possibly, or specify the offset. So what we can do is we could say, select everything from logins, limit 1, which is the offset, and give us 2 results. So what that means is we have 2 results and the offset is 1. So we started at the second entry because we offset it by 1, right? So that means starting from 0, it starts and includes the second record and returns 2 values. So it said, okay, get rid of that first entry. Let's go to the next one, and we just want the 2. So you can do offsets if you're looking for a specific user. For instance, let's say we're looking for user 100, right? We could say limit, and we could do our offset could be 99, something like that, and then say only give me 1 entry, and I would get user 100, right? So there's different ways to do it, but the offset's good to know. You may not use it as often as you think, but it is something you might want to use if you're trying to find a specific person. Now, if you know the ID number, for instance, user 100, I could just say select everything, or select everything from logins where ID equals 100, right? We could do that too, which is what we're getting into next. So this is a little, let you refine it a little bit more and actually kind of dive deeper into specifically asking for certain things, right? This one up here, these select everything from logins with limits. That's going to be more if you're looking for something, but you don't know exactly where it is. You just have a general idea, right? So for instance, it's typical that the admin is going to be user ID 1 or whatever. So you may check there first, and you don't want a list of a million results because it's going to take forever and clutter up your workspace. So you just say, hey, let's just look at a couple real quick and see if admin's in there. But if you actually know exactly where something is, you can do something like this. Select everything from the table where condition. So what's the condition here? Here they're saying select everything from logins. That's the table. Logins is the table ID. Where ID, that's this column here, is greater than 1. So you notice 1's not here, but 2, 3, 4 is. So anything greater than 1, spit it out to us. So if we're looking for 100 here, we could say where ID anything greater than 99, right? That's one example. So now we say select from logins, select everything from logins. This asterisk is just a wildcard saying select everything. So select everything from logins where username equals admin. Now you notice here we only get one result because you notice we actually filtered by username. So we said where the username equals admin. Okay, that's great. But what if we don't? What if we want admin, administrator, all that type of stuff? Well, now we can say the like clause. Another useful SQL clause is the like clause. So we can say select everything from logins where username like admin, and then this % is a wildcard, meaning admin and anything after. That's what it means. Admin and then anything after. And you can see admin, administrator both pop up in the same table where before we only got admin. So that's one way we can do it. The other way is right here, this underscore symbol. Select everything from logins where the username is like and boom, boom, boom. That means right here, match with this exact number of characters, 3 characters, right? All usernames with exactly 3 characters in them, because it can be any letter, but the difference is with the %, it can be 100 letters after, where this we're saying specifically we want 3 letters. That's it. So if we were looking for administrator, for instance, we could do admin, and then we could do, if you look, 1, 2, 3, 4, 5, 6, 7, 8 underscores, and get administrator as well if we were trying to filter out some of the fluff we were going to get from the wildcard. Okay, so now we're actually in. Let's go ahead and exit so that we can completely oh, not clear. That way we can completely start from scratch, and we can see, okay, refresh this target. What is the last name of the employees whose first name starts with bar and who was hired on 1990-0101? Okay, so we got to figure out who's the first one. So first, let's connect to the actual database, right? Let me make sure. Did I just change the IP? I think I did. Yep, I did. Okay, so this is the new IP. Okay, so what we got to change it to what was the port? 46930. So 46930, and then the IP was 94.237. So 94.237, 62.195. Okay, so this command is pretty simple. MySQL, username is root, the host is the IP, and then the port is this, and then this TAC-P lowercase here, that's just saying we want to enter the password. We don't want to put a password in there. And that's just good practice. You never want to put a password in plain text. Okay, and you can see we have the Maria database, whatever you want to call it. And first thing I'm going to do is say show databases. So now we have employees, information, MySQL, blah, blah. Well, we want to go into employees. So we're going to say use employees. Okay, now we're in the employees table. And now we're looking for the name of the employee whose first name starts with bar. Well, first I need to know what tables they have in here. So show tables. Okay, so here we have departments, blah, blah. Well, we're probably going to use the employees table. So now what we're going to say is show or select everything if I can find the wildcard here, there we go. Select everything from, and the table we're going to use is employees, and we're going to say where, and we have to use the first name starts with bar, where, and if you go up here and look again, where, and then in this case we don't know the username, but it's saying first name, so we're going to say where first underscore name, and we're going to say, just like they did up here, like, right? Because we know it needs to be like this, like bar, and then a percent sign because we want the anything after it, right? So we know it needs to be like bar, and then we can say okay, and we want to say, what was it, hire date or something like that. We'll try hire date and see what it says. Hire date, and the hire date was 01/01/1990, right? 1990 01/01. Now this may not be correct, and I'll show you why. Okay, yep, so it wasn't correct, and I'll show you why. What did I do? Okay, so first things first is I'm going to say select everything from employees because I want to see what the actual names are called. So you can see there's all kinds of information here. That's fine. But I need to know the actual names. What are they called? Right? Hire date may not be correct. So we want to see what are they actually called. So it is hire date and it is first name. Okay, so we got it right. That's perfect. So it's hire date and first name. Perfect. Now we go back down and we look at our syntax because it said our syntax was incorrect. Okay. So now we say, and hire date, we did not put an equals. That's why it syntax is incorrect. We want hire date equals that. All right, and there we go. You can see we have Barton Mitchum. He was the only one with the name, first name Bar, and then hired on 1990/01/01. So right there, we say, what is the last name? Mitchum. And we go ahead and we go on to the next one. Okay, now we have SQL operators. So these are what you're going to be using a lot to kind of validate certain things. You use operators a lot when you're doing SQL injection, so make sure you understand them. Okay, so the AND operator, we just used that one, right? We just said where the name is like bar, and we use the and we wanted, you had to be hired in 1990/01/01. So we just used the AND operator, right? So the result of the AND operation is true if and only if condition 1 and 2 are true. So what that means is if you say 1 equals 1 and 2 equals 4, it's going to return back false. That's not true because they both have to be accurate. It's important that you understand the difference because, and if both of your conditions or multiple conditions are not true, you're not going to get a result, right? If you have or, then only one has to be true. So you can see here's an example, 1 equals 1 and test equals test, you get back 1, which means true. That is true. Now, if you do select 1 equals 1 and test equals ABC, test does not equal ABC. So therefore, yes, 1 equals 1 does, but both have to be true. So that ends up being false. So now the OR operator, this one is different because you can say 1 equals 1 or test equals ABC, and you notice it comes back true. Why does it come back true? Because 1 does equal 1, and this is either or. It's not and, it's either or, right? So then select 1 equals 2 or test equals ABC. Neither are true, therefore it is false. All right, now the queries above demonstrate how the OR operator works, which we just did. Now the NOT operator, this is something that you'll use a lot as well, especially if you're needing everything in the database except for something, right? So select not 1 equals 1. Well, this is pretty self-explanatory. If it's not 1 equals 1, then it's not true, right? So the not operator simply toggles a Boolean value. True is converted to false, vice versa. So it's the opposite of true, right? So not 1 equals 1 is false. not 1 equals 2 is true. Pretty self-explanatory. It's just flips, right? So now we say, okay, the symbol operators. So you can use and or not just with symbols. This is something you're going to see a lot, especially when you're doing, if you do SQL injection in like the URLs and things like that, rather than doing them. So if you're actually putting them up here, it'll save you a lot. It also helps with the spacing and stuff like that when you're doing URL encoding, all that stuff. So the and or not operators can also be represented. So and is just 2 and signs, or is just 2 straight pipes, and then not is just exclamation point. And you're going to see us using not with the exclamation point, right? So not equal to, etc. So you can see here, select 1 equals 1 and test equals ABC. So this is the exact same thing they ran before, except for it evaluates the exact same way. It's not true. These are important, like I said, to know because you will use these as you go. So select 1 equals 1 and then the pipes. So or test equals ABC. That should be true because 1 does equal 1. And that's what we get right here, right? So it's important to know the difference because let's say you're doing a SQL injection and somebody sanitizes your output, meaning they do not allow you to run the or command, but they forget to actually sanitize these pipes. You can use the or command then, you just can't use the words OR. So think of it that way. So now you have select and then 1 is not equal to 1, which makes 0, right? 1 is not equal to 1, according to this, right? Because we're telling it it's not. So now let us look at how these operators can be used in queries. So select everything from logins. So again, from the table logins where username is not John. So you notice nobody here's name is John, even though John is in the table, because we said we want everything except for what is named John. Now the next query selects the users who have their ID greater than 1, and this is something you're going to see in the example we use here in a second. So we say select everything from logins, where username is not equal to John, which we did, and you notice we had 3 results here, and then the ID is greater than 1. So this admin is now removed because the ID was 1. So that's why we would use something like that, because we're trying to get very specific here. Now, multiple operator precedence. SQL supports various other operations such as addition, division, as well as bitwise operation. Thus, a query could have multiple expressions and multiple operations. Okay, and what they're saying is they take precedence. And so what they mean is division, multiplication, and modulus, those take precedence over these other commands, meaning these will run first, then addition, subtraction, then comparison, then not, then and, then or. So it's important that you know that, because if you try to say or first, it's actually going to run and first. So what they're saying is here, select everything from logins where username is not equal to Tom and ID is greater than 3 minus 2. Well, look, addition and subtraction happens first. So 3 minus 2 actually happens before the comparison, meaning this will be equated to 1 before it compares it, before it says this. Now that's important because if I was to read this, right, and I thought the order of operations was just simply ID is greater than 3, then that wouldn't be the same thing as ID is greater than 1. So you need to make sure you know what order of operations it's running. So from the parameters, we know that subtraction comes first, so 3 minus 2. So that's why it equates to 1 here, right? So now we have ID is greater than 1 rather than ID is greater than 3 minus 2. It will automatically do that first. So make sure you know those orders of operations if you're doing complex queries. So now we have select everything from logins where username is not Tom and ID is 1. And you can see we get the same results as we did over here, but with a lot more complex of a query. Okay, so now we're still in the same database, employees database, right? And it says in the titles table, what is the number of records? So we know the name of the table, right? And it's what is the number of records where employee's number is greater than 10,000, excuse me, where the employee number is greater than 10,000. Or, well, first thing I'm going to do is the same thing I did before, which is select everything from titles. And the reason I'm doing that is because I need to see what actually I need to see what actually the names of them are. So you'll see, okay, we got employee number is employee number in EMP underscore no, right? And then the rest are pretty self-explanatory. So that's important that we know that, because if you just used employee number based on the name they gave you, it wouldn't work. So in the titles table, what is the number of records where the employee number is greater than 1,000 or 10,000? Well, what we can do is, spoiler alert, they gave you the number right here. But if we wanted to actually do the command the way that you should, it's driving me nuts that when I click in there, it automatically goes back up. So we can say select everything from titles where the number of records, where the employee number, where emp number is greater than 10,000, okay, or title does not equal or does not contain engineer. So we'll say does not equal engineer. Let's see. And we'll say, or title does not equal, we'll say engineer, and we'll see what it says. And look at that, we get 654. Now, that's exactly how many is in the table. Why would we get the exact same result? Because you're saying to yourself, well, engineer is, there's a bunch of them with engineer. But look what it says. Or their title does not contain engineer. Not and, meaning that it's going to equate this one first, and there's all of them are over 10,000 because it starts at 10,001. So therefore, that is our answer, 654. So it's kind of a trick question, just heads up. Okay, we're going to mark complete and move on. Okay, now we're getting into the intro to SQL injections. This is going to be our last module we're going to do, and then we're going to dive into these next time, and then finish out with exploitation, mitigation, and close out. So now we have a general idea of how SQL works, and we can actually go ahead and start learning about the SQL injections. So this is the PHP code example they're going to give us, right? So what this is they have a connection, and that's new, MySQL, localhost, root, password, users. Okay, cool. And they say select everything. This is the query they're going to run. Select everything from logins. Okay. And then the result is connection, query, and then you notice they're calling on the query here. Okay. So they're giving that query. So when you actually put in input, it will change that query. That's what we're trying to inject SQL commands into. Okay, so then the query will be stored right here in result, and we can print it out to the page or use it in another way. So we could say, yeah, print it out and show us what it looks like. Okay, echo, that's fine. We could do that, but that's typically not what you're going to do. You're typically going to use it for something besides just showing on screen. Web applications also usually use user input when retrieving data. For example, when a user uses the search function to search for other users, etc., their search is passed on. So we could say search input, we're sending a post, find user, right? It's saying select everything from logins where username is like, and then put your search input here, right? Okay, well, cool. Then it's going to run that query. Well, we need to break out of that. We need to run whatever command we want, not just put in the input that we tell it. So if we use user input with a SQL query, and if not securely coded, it may cause a variety of issues like SQL injection. Yep. Okay, sanitization. We talked about this before. It refers to the removal of any special characters in order to break any injection attempts. So we could see here, and SQL injection occurs when user input is input in the SQL query. Thank you. Okay, so this is what it would look like, the actual query itself that's happening on the back end of the database. So when you go into a website and you're searching for something, this is the query that it might look like. It'll say select everything from logins, if that's the table, where username is like search input, right? Well, what if the search input is where it's putting in the information that we inserted into the search command in this case, right? Well, what if we change this and broke out, right? So if we put admin, it becomes %admin, right? So that's where it's putting it in. In this case, if we write any SQL code, it would just be considered as a search term. For example, if we input show databases, it would just be show databases, %show databases, right? It would just be in quotes. That wouldn't make any sense. The application will search for usernames similar to show databases. That's not what we want. We want to run show databases, right? So what we can do, and here I think this is a terrible example of what they did, but we can add a single quote, which will end the user input field. So think about this command this way, right? Here's the search input. You see how it's already quoted for us? They will put those quotes in. The actual PHP code will do that. Well, what if we put a quote right here, right? Instead, what if we put a quote right here? That will close that out, and then that means we can start running commands. So if we actually said, okay, put a quote in there, which ends the user input field, then we say show databases, then we end the command, right? It will actually do that for us. For example, if we search for 1, but see how they put a quote in there? They quoted it so that this would be quote 1 quote. So that way the rest of it is actual commands being ran. Then they ended the command and said, new command, drop table users. So right here, I think it's a terrible example because don't ever do this, especially on a pen test. You could get yourself in a lot of trouble if you're dropping tables. You never do that because it's literally like if they don't have backups, you just deleted all their users, right? So don't ever do that. Use something else like show database, show tables, something system info, whatever. Do something besides this. Don't drop tables. So I don't think that's a very good example that they did. Don't do that. But you can see, so the final select query looks like this. Select everything from logins where username is like, and then here's where our normal search terms enter, right? And then we say, and we added drop table users, right? Perfect. Well, keep in mind that this search input is still there. So we sometimes have to comment that out, and they didn't show that here, but maybe we're getting into it a little bit later. And you'll see this will drop the table users, which we don't want to do, right? Now, syntax errors. The previous example of SQL injection would return an error. Okay. And near line 1, near blah, blah, quote, quote, right? This is because the last trailing character where we have a single extra quote right here, right? That is not closed, which causes SQL syntax error. So this is actually called quote balancing. And what it is we have an extra quote in here, and they're adding 2 quotes. So there's going to be quote, quote, quote. We need to fix it. We need to balance those quotes so that there's the correct amount of quotes to close it out. So this is because the last trailing character we have a single extra quote. So we have this extra quote in here. We need to get rid of it. So in this case, we had 1 trailing character as our input from the search query, which was from before. However, the user input usually goes in the middle of the SQL query and the rest of the original SQL query comes after. To have a successful injection, we must ensure the newly modified SQL query is still valid, because if it's not a valid query, it's still not going to work. So we need to actually have balance on that. So one answer is by using comments. So it says they will discuss this later in a section, but basically what that is at the end here, instead of this extra quote, instead of having a quote there, you would comment the rest of it out. So the rest of it is not a valid command. It's not going to run. Sometimes that won't work. And so you may have to just put the correct amount of quotes in the correct places to balance the query out. The easy way to do this is to test this out on your own system. So build a quick SQL database, get the tables to be whatever you want them to be, right? And run the query that you think the website's running and see what's valid, and then try it. Now there's types of SQL injections, right? There's SQL injections in band, blind, and out of band. And then we're going to get into union-based, error-based, Boolean, blah, 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 blah. Okay. So in the simple cases, the output of both the intended and new query may be printed directly on the front end. And that's where we saw here, we got in the actual right here, error, near line 1, blah, blah, syntax error, right? That is in band. And that's because it's error-based, meaning we get an error, we know that we're running SQL commands because we're getting an error directly on it, right? Most websites are not going to show you the errors anymore. That's kind of an older thing. They usually kind of sanitize those so you don't see them, but it's still possible. With union-based in-band attacks, right, which means you're getting direct feedback, you're putting a query in and you're getting a result. We may have to specify the exact location, which we can read, so the query will direct the output to be printed here. So union-based means you're putting two commands together, you're unionizing them. You're putting the command that they want, and then your union and putting another command that also gives you the same results. So for instance, if the command that we run, the query that we run, they give us 4 columns, for the union, we have to request 4 columns. It has to match, and then they will put them all in one table for us to view. And I'm sure they're going to dive more into that. Okay. Error-based SQL injection, it's used when we can get the PHP or SQL errors in the front end, meaning we can actually just see the errors. We can request it, make a mistake on purpose, and it tells us, hey, you have an error in your SQL. That's what it is. That's what in-band error-based is. In more complicated cases, this is known as blind SQL injection, meaning you run a query and you have no idea if it worked because you don't get a response. Did it work? Are you actually running commands on their SQL server? You don't know. So how do you do that? Well, you can do Boolean-based and time-based. Boolean-based is just you make a conditional statement that is true, right? And if the output equals true, then it worked, right? If it's false, so let's say username is, let's say it says valid user or invalid user, right? Like we showed before where it said successful login or failed login. That's true or false, right? Success or fail. So if we run a query, we may not get any output, but we know success or fail. That's Boolean based. It's true or it's false. There's no in between. Now, the time based is something like this, the sleep function. If we have no output at all, we're not getting any response from it, we don't know if it's working, right? We can say something like sleep. Hey, run the query and sleep for 10 seconds. If that page takes 10 seconds to respond, that query was ran, right? It's not normal for a website to take 10 seconds to respond. So that's another blind technique. All right, so, and finally, in some cases, we may not have direct access. So what we can do, and this is called out of band, because we have to output the response to a remote location, meaning, what if we don't have access, we aren't getting responses, we don't know if we're doing anything? We can use the SQL command to do something like look up a DNS record. And if we have a DNS server and we say, hey, look up this DNS record, right? It can reach out to that server. If it touches our server, we know it is working. Even though we're not getting a response on the website at all, it's out of band. It's reaching out to our remote system and showing that it is working. We do have response. So that's out of band. It is a way to basically do a blind injection where you don't know if it's working, but you have to validate before you start just running commands, right? And so you can actually have the SQL Server reach out to a remote location, and if it works, great. That means it worked, right? If you see something. Now, that's hopefully they're going to dive more into that. If not, maybe I'll make a video on it or something. But so now we're going to get into the union-based SQL injection. That's going to do it for this video, guys. I think 30 minutes is the sweet spot for these videos. 30 minutes. I don't want to go more than that because they do get complex, and I want you guys to be able to take them, break them down, and work with them. So next time we're going to, on part 3, we're going to do this, subverting query logic using comments, union clause, union injection. And then the final one, we'll do the rest of them to close it out. So actually we'll probably do these, and then we'll probably do the skill assessment at the end by itself, so that way you guys can just watch the skill assessment if you're trying to figure out the skills. So hopefully this helps you guys. Let me know what you guys think, and if you guys like the content, please hit that like button, hit the sub button. Again, it helps me out tremendously. So thank you guys, and have a great day. Yo, what's going on, guys? Welcome back. Today we are actually finishing up the SQL part 3, and then we have one more after that. We'll have part 4. So we're going to go ahead and go down here and start the boxes so we don't have to do that later. Start that one and then start that one. All right, now let's go into it. So first things, subverting query logic authentication bypass. This is one you're going to see all the time. This is the one that you're probably most familiar with and one that you've heard the most about. So before we get started, hit that like button, hit the sub button, especially if you've seen some of these before, because I'm curious what your guys' favorite SQL injection techniques are, because everybody does a little different typically. All right, so first things first, we have this little admin panel, and you can see we can log in using admin password. So they give you the password so you can actually see what it looks like when it's a successful login. That's very nice. If you ever have a pen test and you're doing a pen test and you work with the customer, if they will give you a valid credential to use, or if you register for it for a site or whatever, it's much easier to do these if you know what a valid one looks like, because you're not always sure what you're looking for at the time if you don't know what a valid one looks like. So let's go into it. The page also displays SQL query being executed to understand. So this page actually will give us the SQL query, so we don't have to guess as to what the query is. It just gives it to us, which is really nice. This is not common. Don't expect to just see exactly what query you're running. There may be some outlying sites that still do this, but it's very uncommon that you're going to be able to break it to give you the exact command that, or the exact query that's being ran. So here's the query. Select everything from logins where username equals admin and password equals password. Makes sense. Pretty easy. Now, this page takes the credentials and then uses the AND operator right there to select records matched to the given username. So it says username is this and password is this, right? If it equates to true, then we're in. So you can see if we say username is admin and password is admin, login failed, it's false. So how can we make this true regardless of what we put as a password? Well, here we're going to start talking about SQL discovery, SQL injection discovery. One thing to talk about here, and sorry, my monitor dimmed on me. One thing to talk about here is the URL encoding. So if you see up here, well, they don't have it up there, but there's times where you'll be doing SQL injection in the URL. When you're doing that, the URL does not take characters like this. So you need to URL encode. So %27, %22, These are URL encoding. You can use CyberChef to URL encode your payloads. You can use all kinds of things, but make sure you understand that you need to URL encode it at times, because if you don't, then you'll be putting these in and you'll be like, why isn't it working? Now, some people may say, well, why do I need to do that if I'm putting them in the username and password field? You can do that, but a lot of people want to do it up here in the URL because you can just sit there and make a payload and change it and try again. You don't have to sit there and go back and retype the username and password. That's why. Okay, so now how do we make it true? Well, we can start with an OR injection. So we would need the query to always be true, right? So we say admin or 1 equals 1. This will always be true because it will check if it's admin or if 1 equals 1, right? So an example would be true because you're basically saying it's true, right? So if we inject that below, we say select everything from logins where username is admin or 1 equals 1. Well, the query would then say and, because if you remember, we're inserting this into the query. And we'll say and, so it would say and password equals whatever you want it to be. That will always be true because if username is admin or 1 equals 1 returns true, which is always true, then the password is something, it doesn't matter because you're giving it a true statement. So that's one way to do it, right? Now this, I'll just tell you, this is pretty, I don't want to say outdated, but this is going to be pretty well known. So you're going to have usually you're going to have defense against this. They're going to have sanitization, things like that. So now we go to authentication bypass with the OR operator. So we're doing the exact same thing. The only difference is you can see here, we put that OR in there. And then here you notice they said not admin or 1 equals 1 and password is whatever. And that's not true. Why? Because it's not a valid user. So it's equating to a false query in total. So what that means is it's going to say where not admin or 1 equals 1. So false, it's going to start with false, and then the next one's going to be false because the username and password is false. So it's going to go false and false. It's not going to ever get to that OR statement. So what we need to do is we need to actually change that and say, hey, we have where username equals whatever you want it to be, or 1 equals 1, and then we need to put it in the password field also where it's whatever you want, and then 1 equals 1. So we can't just put it in the username field, which is right here. You need to put it in both, or else it's going to equate 1 to false and 1 to true, which equates to false in the grand scheme of things. Okay, so now try to log in as the user Tom. What is the flag value after you successfully logged in? Okay, so one thing to do, just FYI, they have this nice cheat sheet here. It's very nice. You can see, easy way to do this is just save this or copy this so you don't have to do it again. Go here. Now, we just have to change, and the IP is 83.136. So we just say 222. 83.136. 136, 253, 251, and then 250. Yep, I did not put another period there. 253, 251, and then the port is 36386. So 36386, 36386. The username is root, so that should be good. I believe so anyway. Okay. All right, so what we need to do, that is how to log into SQL, which doesn't help us at all in this, so that's my bad. I wasn't paying attention to the question. It's asking us to log in as Tom. So what we're going to do is go down here and go to this website. And hopefully it's got a login. There we go. Inlane freight. Now, we need to log in as Tom. So we're going to say Tom. So that's the username. And you can see if we go up here to, and we know Tom's a valid user because they're asking us for it. So that's one thing to keep in mind, is that if we didn't know Tom's a valid user, then we might have a question. But what we can do is we can take this or 1 equals 1, right? And we can say Tom, and then we can say, go down here to the password, and we can just say quote space control V, hopefully it worked, or 1 equals 1, don't save. And you can see here, okay, from logins where username equals Tom and password equals whatever or 1 equals 1, login successful as user admin. So we're logged in as the user admin, which is not what we wanted. We want to access the user Tom, right? Okay, so we need to log in as Tom. So let's do this. And if you remember, in order to log in as the user Tom, we had to take, or as anyone, we had to do this. So we had to do this, and we'll do the same thing, but we'll change it to Tom. And then we'll do the same thing down here. It doesn't really matter what you put down here as long as it equates to true. Don't save. Okay, and it says here where username equals Tom or 1 equals 1 and password equals admin or 1 equals 1. Okay, so once again, we're logging in as admin for some reason. Let's see what are we doing here. What's the issue? Because we're logging in as admin, which is great. We don't want to log in as admin. We want to log in as true, because you can see here that's what they're giving us, is log in as admin. So let's do this. Let's log in as Tom, but we'll say 1 equals 1. But we're going to put a password in there that's whatever. So that way it equates to true, but we're never giving it the option for admin. There we go. So we never gave it the option for the password because what was happening is it's just saying true, true, move on, and that's admin. So we're going to actually say So if you didn't see what I did, which hopefully you did, all I did was say Tom or 1 equals 1 to equate to true. And then I said, and the password, whatever. It doesn't really matter what the password is. So that's why it says ASDF, whatever. So now we can go down here, submit our answer. Nope, not that. Didn't want the help center either. Come on. There we go. All right, we got our streak going. Great. Mark it and let's go. Okay, so now we're using comments. So this is actually one thing I really like to do in SQL is comments. So you can use comments to basically get rid of the rest of the query. So what was happening in some of the previous examples with Tom was it's reading the rest of the query. So it's saying Tom is true and then it's reading the rest, right? We can comment all the rest out. We can just say Tom equals true, end of story, end of query, right? And that's what we're going to do with comments. So you can see here they're saying select username from logins, and then they use this double dash here to select usernames from the login table. That's just a comment. It's not executing anything, it's just a comment. So that's really nice. Now you can see these comments are inline comments. So that means like right here, if I wanted to do select and then I put a comment right there, I would use this. But if I'm doing it after, just that. So that's the difference between the comments. So you can see here, you can also use the hashtag. They talk about that here, that there's this one, hashtag, and then inline comments. Okay, so you can see here, they said auth bypass, the same thing we just did, but with comments. They would say admin, and then they would just do the comments. The reason they do that is because they're saying select everything from the logins where username equals admin. That's it. End the query. I don't need to check the password. Just end it. And that's what they're doing here. So this is very common. That's not going to work, but it is cool to see, right? It'll work if you use comments correctly. What I'm saying is the specific one they're using where they just say admin, comment everything out. They'd usually have sanitization for that, but comments are a very big part of SQL injection. So SQL supports the use of parentheses. So here's an example where they used it, and see how they did it. The whole query had parentheses in it. Well, when you comment out this, when you comment the admin out, look at that. There, you didn't finish the parentheses. You didn't close it, because what's going to happen is right here. Let's see if we can find it. Yeah, right here. See how they have the comments here? Well, you didn't close this parentheses, because what it's saying is with these comments right here, it's saying forget all of this. Forget everything here, because what they did is they hashed the password here. That's why there's a hash there. So you can forget all this. Well, the problem with that is that you opened a parentheses here. You need to close it here. So you can see they change it and they add a parentheses and then the comments, and that actually closes that loop and then allows it to run. So make sure you know how to close that. Make sure you know SQL queries. But the one thing I don't like about them teaching this here, they teach it very well. I don't mean that. What I mean is, I'm going to kill my dogs. But what I mean is that the problem is a lot of times you're not going to get an error back. You're not going to get an error back. You're going to get nothing back. So when you do when you do a SQL injection, so you wouldn't know that parentheses is there, right? So that's why you need to know what to test. That's why you need to know this exists, because there's times where you're going to have to check this, right? You're going to have to, well, it didn't work like this, so maybe if I put a parentheses, maybe it'll work if I do this, because you're not going to know the query on the back end, right? This is why when you're pen testing, I tell people all the time say, I want to do a black box pen test. I want to do it like the attacker does. Okay, great. You know what the attacker's going to do? He's going to sit here and he's going to try them all, because he's going to eventually find the one that's right. You know what you could do? You could just go ask the SQL database admin as a pen tester, hey, will you just tell me this query? Show me what it's doing. Because if you just show it to me, I can just tell you if it's got SQL injection, right? I can look at it. I can craft a payload very quickly. So don't get hung up on doing it like the attackers. If they'll give you information, it'll save you so much time. What is impressive? What makes it impressive that I can sit here and guess every single SQL injection attempt versus somebody that goes, hey, can you just show me your SQL command and I can just create a payload, and if it works, great, we know. There's nothing more impressive about it. They both know SQL. So that's why don't get hung up on that. I see that a lot. Just ask the information if you're doing a pen test. It saves you a lot of time. Okay, so now you can see the login failed due to a syntax error. They added that parentheses and boom, it worked, because the rest of this is commented out, meaning none of this is valid. It's just a comment. So now it says, here we go, select everything from logins where username. Yep, that's the new one. Okay, so now it says, click here to spawn the target system. So there's a new target, and it says login as the user with ID 5 to get the. All right, welcome back, guys. Sorry about that. My dogs were going nuts, so I I had to stop the video for a second. Okay, so where were we? We were trying to query above. Okay. All right, so log in as the user with ID 5. Okay, so we know that if we type anything, right, we want to see what the error is because we know we have error-based SQLi here, so we can actually look. Okay, so here's what the actual quote or the actual thing looks like. Okay, so we know username equals blah 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 whatever admin and ID equals greater than 1. Okay, so we need it to equal something greater than 1, which is admin, right? So we know that. So now we can go back and we can just say, let's just do that, blah blah, haha. Doesn't really matter, right? And we want to say we want to give it an or statement, or ID, equals 5, right? Now, what we're doing here is we're just simply saying, hey, if it's equals 5, we're good. But we saw before on the quotes, or I mean on the query before, that it had a parentheses in there. So we need to close out that parentheses. If you don't close it out, you're going to just basically do nothing. Okay, and then we're just going to say password, doesn't matter what you put, don't save. Okay, so now it says haha or ID equals, okay, ID equals 5, and that's fine. That's because I have a space in there, so I just noticed I had that space in there. Okay, and we can say or ID equals 5, and we'll try it with no password and see what it does. Okay, now it says you have an error, just check the manual, da da da. All right, let's get rid of anything. Let's not put anything in there. So, and then, so we're not trying to, because it's an invalid user. Let's try and do, and I'll put a password. It doesn't really matter what you put. Okay, and we don't have a password here, so we'll have to actually figure this out. All right, so I wish it would not make me go back, which I could do it in the URL, but okay. So we can try other comments as well. So not the $, but maybe they're sanitizing those quotes. So we'll do a hashtag here, and we'll just say, hey, password. Doesn't really matter what you put the password, right? Okay, there it was. So what it was they were sanitizing those quotes. Perfect. So login successful as super admin. Okay, so user 5 was a super admin, which kind of makes sense, but not really. But okay, either way. Login is to get the flag. Oh, here's the flag. Okay. So all we had to do was tell it that we were going to use user ID 5 because username blank or ID 5. So either one, and username blank doesn't exist, so ID 5 is the next best, and then the password, whatever, doesn't really matter. Okay, so there's our, give me my little streak, there we go. Okay, mark complete and move along. Okay, so union clause. Okay, so this is what I was talking about earlier in some of the earlier videos. If you guys watched some of the earlier videos, we were actually talking about the union clause and how the columns have to line up. I didn't really explain it very well because I didn't have any visuals. This actually will give me a visual to show you what I'm talking about. So union, what is a union statement? So here's a good example. I'm not going to read it. I'm just going to explain it. So here they're selecting everything from ports, the table ports, right? And they get code, city, those are the columns. Code and city are the columns, right? Well, what if they wanted something like this? So they say select everything from ships and they get one ship, Morrison and the city, right? Well, what if they want both of these, right? Yes, they could do two queries and say, give me exactly this, select everything from ships, select everything from ports, but you could combine them. So for instance, what if I had an HR system and a, I don't know, a finance system, whatever, right? And they both have usernames and work IDs or something, right? I could just combine them and make one large query that does it, that gives me both of them. But in order to do that, you can see select everything from ports, union, and combine that with select everything from ships, and it combines all of the answers. This is very common. Like I said, what if you have databases that just have segregated data, but they have the same types of data? You can just do two union statements and boom, 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 and it'll print them out together. So That's really nice. The problem with it is that you have to have the same amount of columns. For instance, if this table had 4 columns and this table had 2, you can't do a union statement because it's not going to print out correctly, right? So how do we get around that? Well, you can see here they're telling you that you have to have even columns, right, with an equal number of columns, which is true. So you have to have that. You have to have those same amount of columns, but there's a way to get around that, and we'll show you. The above query results in an error. So this is what it looks like when select city from ports. So they only selected the city, and then they selected everything from ships. So if you look, if they only select the city, but then they select everything from this table, the columns don't match up. They're selecting 1 here, they're selecting 2 here. The columns don't match up. You get this error. The use select statements have different number of columns. Really nice, but you may not get an actual error when you're doing this, right? So when you're doing this, you want to make sure you have the correct amount of columns. How do we do that? How do we validate them? Well, what we can do is put this junk in there. So what that means is we can give it data and say, give us this data with this data. And the point of this, you'll see, is we're giving it junk, quote unquote, because it's not in the table. We're giving it the information. So we're saying select everything from products where product ID equals 1. Okay, pretty easy, right? You're going to get the product that ID equals 1. And then we say union select, and we're saying username 2 from passwords. So we're providing it the data. We're giving it a number 2. So we're giving it the data. It's not in the table. We're giving it to it. And then you can see we say select username 2 from passwords. Well, if we had more than that, we would say select username 2, 3, 4 from passwords. So that's how we're supplying those columns for it. There may not be a column named after username and passwords, right? Those may be the only 2 columns in your table, but we're giving it these columns to match the same one. So it would look like this. If there's 4 products, right, we have to have those same amount of columns or else we can't combine the information. So we say select everything from products where product ID, that's this. Everything from products where product ID, whatever. Then we say union select username, right, from the password table, but we will only get the results if we match the same amount of columns. So we said 2, 3, 4. This is 1, 2, 3, 4. So it provided 2, 3, 4 for us. It put it in the table for us in the response, not the table. Now the reason this is important, you might be saying, why would I ever do this? It doesn't make any sense. The reason it's so important is because what if they block or sanitize your commenting and all that other stuff, right? Union is a way that you can also pull data. So that's why they're giving you this information. So let's go see if we need to get another box here. Yep, spawn this one, and we'll get rid of this one. Okay, so now what we need to do, we need to actually go and there we go. These come up very quickly, actually. I'm pretty impressed with that. Paste and go, see if it's an actual website. Okay, this isn't the website, this is an actual database. So what we're going to do is we're going to say connect to the above MySQL server with the MySQL tool, find the number of records returned when doing a union of all records in the employees table and all records in the departments table. Okay, so what we need to do is port was 33894. Okay, 33894, 94237. 237, 253, 3, perfect, and root and password, perfect. Okay, so now we can say show databases, even though it kind of gave it to us. For some reason that doesn't look right. Okay, so we have employees information, so we're going to use employees. Thank you. Okay, show tables. Okay, so we have departments. They told us which ones to do. So find the number of records returned when doing a union of all records in the employees table and all records in the departments table. Okay, so we need to see how many columns are in each, right? So we're going to say select everything from employees table, right? Select everything from employees. Okay, and we see we've got a lot of records, but looks like we have, whoops, I'm not even going to go to the top, but it looks like we have 1, 2, 3, 4, 5, 6 rows, or 6 columns, excuse me. I can't tell if this last one is a column or not. We'll see. So now we're going to say select everything from, and the other one was departments, right? Departments, yeah. Select everything from departments, just because we want to see how many rows. Okay, and they only have 2, so we're going to have to provide some junk in there, if you remember the junk, quote unquote. So what we're going to do is we're going to say, if we go to the top here, we're going to look at the rows, right? Come on, there we go. So we have employee number. Okay, so that is a number. 1, 2, 3, 4, 5, 6. Yeah, so there's only 6 of them. Okay, perfect. So 6 columns. Boom. Okay, and it's asking us to go ahead and okay, do a union of all records in the employees table and all records in the, okay. So if we do, we're going to do it from departments, right? So, or from the employees table, because it has the most. So we're going to say select everything from the employees, right? And then we're going to say union select, and we're going to say department number, because we need to specify these ones. Department name, and then we're going to say we want, this is 3, 4, 5, 6, right? Because we need 3 from departments. And then go ahead and, we don't even need to do that. We just need to do that. Okay. And we'll say enter. Okay. And we got 663. Now you notice here's the end of them. We got customer service development. Then we have 3, 4, 5, 6. Now that's where I unioned, I combined them. So, and then it tells us the 663 rows. Now, is that correct? Let's see. 663. Boom. There we go. So we unioned the statement. So you can see up here we have the birth dates and all that, our hire dates and the names and all that, but we combined them. So you can see what can happen is if I have access to this database based on the query I'm doing, based on the search field or whatever, I can union, combine, and pull information from other databases. So that's kind of the key here. That's what we're looking for. So we've got that. We submitted it. I believe it worked. Yeah, it's marked out. Okay, let's look at it. So now we're on to the last one, the union injection. So this one, I'm going to go start the box before we start, because we've already covered union, so I'm assuming you guys will pick up on this pretty quick. All right, so union injection is the same as before. The difference is how do we view it in an injection environment, not on the database environment. So you can see this is searching for a port. So they're searching for a port for whatever, they're shipping stuff, I don't know. And so we went ahead and they put a quote in there just to cause an error so that we could see what the database looks like. It caused an error. Okay, cool. So now we need to detect the number of columns. This is what we already kind of did. One of the ways we can do it is using order by. So what it is we're going to say order by 1. Okay. And if you look order by 1, it's going to order by this column, or this column, right? Cool. That's fine. I don't care how it orders it. What I'm trying to see is how many columns are there? Because if it's ordered by 2, it'll order by this column, right? That's great. That means there's 2 columns. What if it's, because here's the thing, what people don't realize is, and we'll show it here actually, is we do the same with 3 and 4 and get the results back. However, we try to order by 5 and it doesn't work. So we have 4 columns. Well, we have 4 columns. It's only displaying 3. So what you get back on a website doesn't mean that's all that's in that database. So in order for you to use a union statement, it has to match what's in the database, not what's being displayed to you on the website. Now, some of you may say, why is that the case? And you'll see. So you can see now here they do select 1, 2, 3. Doesn't work because we know there's 4, so they do 4 and they get 2, 3, 4 because they put 1, 2, 3, 4, right? They put these numbers in there. They put junk in there, quote unquote, right? So now we have to know, where do we locate our injection? That's why they number them 1, 2, 3, 4, because look, now I know if I'm going to do my injection, it needs to be in 2, 3, or 4, or else I'm not going to see the data, because if it's in 1, I don't see it, right? And there's many times this might happen. So they did here, they put at version in their database, and it'll give them the version of the database they're using. And you can see it actually printed out here. Now, some of you may say, like, why would you not display the full data? Well, what if one of the columns that you don't want displayed on the website is like the primary key of the database, meaning it's just a reference for other databases, right? I don't need you to see the primary key of the database. So 1 would be labeled out then in that case. So let's go ahead and minimize that, and let's go to this one. All right, well, maybe. Okay, so now we're in. We got the search for a port, right? And what's it say to do? Use a union injection to get the results of user. Okay, so all we got to do is say, basically copy what they did, right? So we can say search for a port. Okay, well, we want to say we're going to do the same thing they did, which is CN. We can actually just copy theirs. CN, we'll just do this exact one and see if it works. If it works, that means we got 4 columns. We don't have to go chase it down, right? So we're going to do the exact same one. Does it work? It does work. So it's the exact same database. So we have 4 columns, right? So now all we got to do is inject our column somewhere else. So we're going to keep that, and I'm just going to inject it in 3, right? And we're going to say user, because I want to get the information from the results from the user. Okay, so user search, and there you go. That's who I am. That's the SQL command I just ran, which is who am I? What user am I, right? And it's root at local host. So all we did, if you don't fully understand this, it's fine. All we did is we said, okay, search for port CN. Doesn't matter what you search for. You can search for anything here, right? Then we're combining that with select, and we're adding this information 1, which 1 doesn't exist. And then we're saying at version, which is what this result is. Then we're saying 3, which is this result, and then 4. The reason we have to put 1, 2, 3, 4 in there is because the union select statement that we're making doesn't have any data, and the columns have to match. So it doesn't have 4 columns or 5 columns. It only has what we tell it. So we're telling it we want 4 columns to match this, so we can do a union statement. So now it's saying, I guess just give it the results, root at local host. All right, there we go. All right, mark that, and we're done. So hopefully this helps you guys. That's going to be it for this video. We are going to finish up with the SQL or the exploitation and the mitigations, and then we will do a whole video on closing out the skill assessment, and we'll knock all of that out. So hopefully this helps you guys. Hopefully you guys like the SQL injections. I think the SQL injection is one of the most fun to do. It's a lot of fun. It's hard. It's a puzzle every time, regardless if you've done it 100 times. So that's what I like about it. Hopefully you guys like it too. Let me know in the comments below. Let me know. Like the video if you haven't yet. You know what I mean? Just like it. Just like it. All right. Thanks, guys. Have a good one. Yo, what's going on, guys? Welcome back. Today we are on the final video of the SQL injection fundamentals before we get to the skill assessment. So I'm going to finish this one, then I'm going to do the skill assessment, and then I'm going to post one video of all of them put together. So if you really want to, you can sit there and watch a 4-hour video or whatever. It's going to be 3 hours, whatever, and go through the whole thing if that tickles your fancy. So before we get into it, I do want to go ahead and tell you to hit the like and subscribe button. As you know, I gotta say it. I appreciate it. It's the only way my channel grows. The other thing I want to point out is I did record this video and post it yesterday. And if anyone uses OBS, you know, sometimes it just changes your settings, and it changed my settings and I didn't record any audio. So I verified this time, and I'm double verifying right now that there is audio, so we should be good. All right, so let's go ahead and get into it. So MySQL fingerprinting. So if you remember where we left off last time. We just finished the union injections, and now we're going to go into the fingerprinting. So what that means is trying to identify what SQL database we're using and what tables, columns, and what schemas or databases we're using as well. So you can see here that you say here as an initial guess, if the server is using Apache or Nginx, then it's a good guess that it's using something like MySQL, right? Because that's the database management system. Now, if it's Microsoft, it's probably using MySQL. So these are, the reason this is important is because everything they're going to show here has pretty much an equivalent, whether it's the same exact command or not, it's an equivalent in the alternative. So if you remember, we already did this at version and we got that Mariah database there. So you remember that. That's what we're going to be going off of. So we're going at that conclusion that that's what this is. As we know, if you remember also, we validated before that there's 4 columns that we have to match in order to do a union statement. And one of them was here that we don't see. The other one was this, then 3, then 4. So there was a total of 4 that we had to do. And that is why we know we're going to be using that payload the whole way through. We're just changing what we're looking for. So first thing, I'm going to start the instance. I'm going to go ahead and down here and start the actual, this bad boy, so we don't have to wait on it. Go back up. Okay. And so first thing we have to do is get the information schema. So what that means is we're going to ask the database information schema for information about the database, about the schema, right? So what it's saying here is you can do union select. So this is what it would look like if you're just doing it directly on the server. Select everything from mydatabase.users, right? But we're not going to do that because we don't have access directly to the server, right? We are using a SQL injection. So we're going to use this schemata. So what you do is the table schemata. It's a table in the database. As you can see, information schema right here. We're going to be using that table to gather information about the database. So you can see we say select everything, schema name. So we want the schema name here from information schema.schemata. And you can see right away, it's going to grab us that and list all the schemas here. So these are all the databases, but the reality is we're doing this on a union select statement, so we don't do this on directly on the server, but we need to know what query we need to actually use. So you can see here's their payload. They're using cin. You can use whatever you want there. Then they're saying union select and they're saying 1. Then they want the schema name. And then they got to finish the columns, because if you remember, we have to match the same amount of columns that they're asking for. If you don't do that, then you know what happens. It won't work at all, and it will tell you improper matching. So then they're saying schema name. Then they're saying 3 and 4 from information schema.schemata. And what that's going to do is that's going to actually ask this information schema for the list of schema names. And you see we get them right here. We get information schema, IL freight, dev, performance schema, and MySQL. Now, the nice thing is some of these we know are going to be generic or defaulted, right? So we see 2 databases, IL freight and dev. So there's IL freight, there's dev. The rest are all default, meaning that they already come in pre-installed, so we don't have to worry. Yes, we could use them to gather information like we are with information schema, and the reason we use that is because we know that that is going to be in this database language, so we know we can pull information from it. So therefore, why not use it? Because otherwise we have to know the names of the columns that we're trying to pull. So that leads us to our next point, is how do we get the columns once we have the database, right? So you can see they're using the union select 1, database 2, 3. Now you may say, why are they doing this? It's to figure out what database are we currently in. So when you do a search on here and you're searching for CN or whatever it is, excuse me, when you're doing that search, you need to know what database are we currently in that we're running these commands on. Because if we're in dev or whatever, right, we're going to get different information. So we know if we do the select database there, it will print out what database we're currently in. And we're currently in the IL freight database. So that's great, but we're actually going to start grabbing information from dev. That's what it wants us to do in this example. And you can see we say, okay, how do we get the tables? So we know the database already. We got that. And each time we have to match those columns, 1, 2, 3, 4, right? And we know we're in IL freight, so we're going to have to ask for dev every time, because that's the table that we're looking at, or the database that we're looking at. So now you can say union select 1, because you got to always specify 1, 2, 3, 4, right? And then we want the table name, right? Because we want to list the table name and the table schema. So what table and what schema is it in, right? And then we say 4. And then we say we want it from, and if you look, we use the information tables or information schema again, and we say dot tables. So now we're going to say ask the information schema for the list of tables where the schema equals dev. So only give us the dev schema, right? And you can see here's a list of the different credentials, or I mean of the different columns or tables, excuse me, in the database dev. So you can see there's the validation that they're all in dev, and there's a table called credentials, one called posts, one called framework, and one called pages. So now we know the name of the tables, so now we can go into the tables and start listing off the columns. So now we change it. It's the same payload, but we just change it from tables to column name, and then we want to list the table that it's in, and then the table schema. You don't have to list these because you know they're in there, but it's nice because it validates what you're looking at, right? And then you scroll over and you say it's from information schema dot columns instead of dot tables, where table name equals credentials rather than where up here where table schema equals dev. We're saying where table name equals credentials because we know the name of the table now. So now we simply say, okay, cool. We asked it for now all the column names and the table names and the table schema, excuse me, all three of them from everything in the credentials table. So all we have is we have a username and password. Those are the two columns in that table. So that's pretty easy because that means we only have two things we have to look for: username, password, username, password. That's it. Well, luckily for us, we actually have 3 things that we can print out here if we use these columns. So that's easy enough. We can say, okay, union select, again, same payload, 1, list the username and list the password from, and you notice we say dev.credentials. So we're telling it in the schema dev, go to the credentials and list username and password. And you can see there they list them. So now here's the nice thing. If we go to the website now, and we're going to go right here, copy. All right. Make this larger. Okay, so now it says search for a port. Well, we can just copy this exact thing because if you look, it tells us what is the password hash for new user stored in the users table. Okay, but if you notice, so let's go ahead and copy this because they have our payload for us, so we don't have to get crazy with it. There we go. But we have to change it. Nope, didn't mean to do that. Go here. We have to change it. There we go. I just copied it twice. All right. We're all over the place here. Okay. There we go. So the big thing is, 1, we don't need the dev credentials, right? Because if you remember, we're already in the ill freight database. That's where we're located. That's where this is actually pulling from. And if you read, it's asking us to get it from the ill freight database. We're already in that database. So if you've been working on this and you've been getting weird results and you're using that dev database, that's why. So we're just going to ask for the username and the password, right? From, oh, doesn't have a username list. Okay, perfect. So let's go ahead and back and let's look at what we need to actually do. And what we're going to do is we're going to grab, so we know we need to be in the ill freight database. So we're going to grab this. Let's see what it says. What is the password hash for new user stored in the users table? Okay, so we just need to get rid of the user name and put users. So let's just grab users, right? Not because, or user, not username. That's what it was. So if you look, it tells us new user stored in the users table. So we're going to say select 1, and we're going to say user because we need to know the user, right? And we want to know what's our current user for 1. And then we want to say, and then 4, right? Because we're going to go 1, and then we need 3 because you got to match all the fields. So 1, 3, 4, we say search, and there's the root. So that's who we are, right? So right away we know that we're root currently. Well, that helps us out a lot because that actually tells us we actually have unlimited permissions. We can do whatever we want here. So that's really good to know. And then we know, okay, so I keep forgetting that's not a thing. So now we say username, right, and password, but instead of this dev credentials, we want from users because that's the name right here of the table, users. So we don't have to put dot anything. The dev dot is something to access a different table. We're in the table we want. So we want username and password, and then make sure we get the comments out. Yep, commented out. There we go. And we want the new user one, right? Super easy, super simple. So there you go. And the reason you may have asked, why did you figure out if you're or what user you are currently? It's because I wanted to see if I had permissions to actually access this stuff or not. They talk about that later on, but I wanted to do it because I actually got mixed up once on this when I was doing it before, and I spawned the wrong spawned the wrong one and was answering the question on the wrong one. So here is the new user. Boom. Now we say submit. I already did that, obviously. Again, I've recorded this video once before. So now we're going to read files, and this is where I jumped ahead actually. And you can see it says select user current. We're trying to figure out if we have access to read a file. Well, I jumped ahead, right? I already knew, again, I've done this once, so I actually was jumping ahead, but I knew we need to figure out what user we are. Well, if we're root, you can do this if you want. You can select super privileges and all that to see if you have the super privileges, because that's what it's doing. It's telling you first, figure out what user you are, right? Once you figure it out, root, I've already figured that out. I am root. Then I am root. No, I'm root, just kidding. Now select super privileges from MySQL. What this is to see if you have super privilege access. I'm not going to do that. You can feel free to do that, but knowing that we're root, I'm very confident that we have the privileges that we need. And you can see here, if you do it, you actually get a yes, meaning yes, you do have the super privileges. So that means we actually have super user privileges and we can do kind of whatever we want. And then you can see here, we can grant, right, our privileges. And what that is just going to show you all the privileges. And you can really go in here if you want and see if you have everything. But you have what we need, because the one that we're looking for is this file privilege. That means we can mess with files on the system itself if it allows it, right? So keep in mind, whatever files you have access to on the system is dependent on the service or the account that is actually running the SQL database. So for instance, if you're using a low-end user that doesn't have any privileges to run a SQL database, if you take over that database, that's all the files they can access. Keep that in mind. So in this case, Etsy password is a globally readable file. So you can see they're saying select load file, and they're just saying Etsy password. And when you do that here with the union select, like we have been doing, like 1, 2, 3, 4, you actually can see the Etsy password file. Now, the reason they do this is because they want you to do a globally readable file just to see if it's possible. So always use something that you know is globally readable, like the Etsy password file. So now another example would be here. They're going to load the file. They're going to load var www html search.php. And what that's going to do, because you can see the default Apache web root is var www html. Fair enough. And the search.php is the script that is running. If you look at the source code of the website, it's the script that's running this search function. Well, we want to read what is that script doing. So you can see when they do it, the difference is when they look at the source code, it'll actually be in there, and it will be in there. Here's the best part, with actually readable. The PHP script will be there readable. If you don't do it this way, if you just look at the source code, all you're going to see is PHP script, and when you try to access it, it's going to run it automatically, and you're not going to be able to read it. So this gives you a chance to read it, which we're going to take advantage of here. So we see in the above PHP code that con is not defined, so it must be imported using the PHP include command. Check the imported page to obtain the database password. Okay, so let's go ahead and do what they did to look at the source code. So we're going to do this exact command. copy it. Oops, scroll down. Paste it. Okay, now it doesn't look like we got anything, but if we hit Control U, we go down, scroll through. Wow, that's actually kind of blurry on my screen. Here you go. So if the ISIT get port code, select from everything from ports where code is like, and then you can see here's the con, right? And that's the and that's the con that they're talking about is not actually accessible. And you can see what they mean by that is, or not accessible, I'm sorry, it's not predefined. So that's where they're saying, hey, if this isn't, since it's not defined somewhere else in this code, it has to be defined somewhere. Well, luckily for us, it's defined somewhere else. Well, if you guys know PHP and you know how this works 95% of the time, and I say that only because I'd never want to say 100% of the time, there's a config.php file. And this is going to actually tell these PHP scripts how to run, what to validate, all that stuff. And the nice thing is, if we, oh, look at that. I didn't even have to actually do Control U. Here's the script itself. And we got database username is root, database password is flag. So right there, we were able to pull that. And I get the question a lot, like, how would you know that? You know, how do you just know that? Whatever. That's just from experience from working with PHP and trying to read enough PHP config files that typically that's where it's at. And you can see here, that's fine. It doesn't mean that you don't know anything or anything like that. You could easily look up Apache PHP configuration and figure out that the config file is right there. So it wasn't a guarantee that it was in there. That just happens to be how this box is done. So don't take it as me knowing more or anything like that. Just take it as, oh, now I know that there's a config.php file typically, and I can use that and access it accordingly. So one thing I'll tell you here is now we'll go to the next. And when we do go to the next, I have to end this one. This is one I took too long on. There we go. And I'm just going to go down and spawn this one because I accidentally, this is the one I'm talking about. I accidentally spawned the wrong one and went to another step and thought it was the same box, and it was giving me an incorrect permissions issue, and I couldn't figure it out, so I had to break it down. So writing files, when it comes to writing files to the back end server, it becomes much more restricted. This is true in modern database management systems, since we can utilize this to write a web shell on the remote server. So what they're saying is we may not be able to write the file on the operating system, meaning we won't get a reverse shell on the operating system necessarily, but what we can do is we can use it to get a shell on the web application, which then is basically running commands on the back end for us. So what we're going to do, you're going to check, these are the things they're telling you to check. We require 3 things. User with file privilege. So again, we know we have file privilege. That is asking if the file, if meaning we can edit the files, the global secure file privilege variable is not enabled. What this means is, and you'll see, user determine whether, so where to read write files from. So what this does is, if this is enabled, it will only allow you to read and write files from a specific secure file path. Okay, so if that's enabled, that means we can't step outside of it. So it's not really helpful for us to try this reverse shell now, or this shell in general, this web shell. Now, however, MySQL, because this is not a reverse shell, I apologize, but however, MySQL uses var lib MySQL files as the default folder. This means that reading files through MySQL injection isn't possible with default settings. Okay, even worse, some modern configurations default to null, meaning that we cannot read write files anywhere within the system. Okay, so that's good to know. So let's see how we can find out the value. Well, we just say show variables like, that's if you're on the SQL server, but if not, you have to do a select or a union statement, and you can see here's the union statement. It's union select one. We want variable name, variable value, and again we're going back to the information schema and we're saying global variables, where the variable name is secure file privilege. And if you look, it's empty. What does that mean? Nothing in there. That means it's never been set, so we can actually use it. Now, select into an out file. So this is where we're going to tell it write something into an out file. Now you can see here, they selected everything from users and they put it into this out file, temp credentials. Okay, pretty cool. Because then we could go on the website and we could access this file theoretically, right? That's fine, but how does that help us, right? Well, that's what we come into next, right? So here you can see this is all based on the server code, meaning if you are on the SQL database yourself and you say select this is a test into out file temp test.txt. This is just SQL language. And then if you cat the temp test.txt, there is a test file in there called this is a test. Now, and you can see it gives read-write permissions across the board right off the bat. So that's nice. And you can see this is a good little tip. Advanced file exports utilize from base64 in order to be able to write long advanced files, including binary. So what that means is you can export and write executables from base64 into files for yourself. So that way you can actually export them and they're only going to be in text. So it's actually a really nice tool. So now select files written successfully into out file. So this is just going to say select file written successfully. And then you can see, if you notice, look where they're writing them to. var www html proof.txt. So this shows proof of concept, because if we're on the website and we go to var www html proof.txt, which would just be the website proof.txt, then it should say file written successfully. If it does that, because you can see here's the union statement, union select file, and we'll do this right here just to show it, right? Okay. So we go here and we go, let me copy this first. Because we had to spin up a new one, don't forget. Okay, there's that one, and then we'll go back up and we'll do this as a proof of concept, because you always want to test things and show proof of concept before executing, because if you just try to execute, 99% of the time you're spinning your wheels because you're testing stuff and you're writing files to them every time. So we say proof text. Now we can go here, instead of search.php and all this jazz, we can just say proof.txt, right? And if it worked, look at that, file written successfully. And you can see we also still have the 1, file written successfully, 3, and the 4. So if we wanted to get rid of that, which we'll talk about here, you could just put quotes there instead of the 1, 2, 3, and 4, and that just would put an empty nothing in there, right? So what we're going to do now is we're going to put this PHP system request 0. This is simple one-line PHP shell. And what it's going to do, you'll see here, we're going to put it in. We're going to write this to out file to shell.php. Now, some of you may say, what does this do? Well, this is saying PHP, use the system and run whatever 0 is, right? And you can make that whatever you want. It doesn't have to be 0, but run whatever 0 is. So you might say, well, what's 0? I'll show you. So if we go here and we say search, right? Now, all that did currently is it wrote to the shell, right? The shell.php that we just created. So now instead of this search.php, and we got to get rid of all this crap again. And you can see that %2, %2, %3, all that is URL encoded. So if you ever get stuck where you can't get something to work in a URL like that, take it to CyberChef and URL encode it. It'll save you a lot of time. Okay, I don't know what happened. Did it freeze on me? Okay, the box might have froze on me. Okay, let's see. I think it froze on me. All right, we'll start it back up and we'll start from scratch, which is fine. If it froze, no big deal. We'll go through and we'll talk about it here. So you're going to run this and request, right? Run it. And you saw that we didn't get a response. That's good. No response means it ran. We didn't get an error. Now, when you go to here, you go to the server and you type shell.php because that's what you just wrote to. That was the out file you put. You make 0 equal whatever command you want to run. So if we go here and we go back to here, there we go. And we say here, I made that full screen. It still didn't work. Okay, there we go. Now we go back to here. We copy this whole shebang. And we say search. You'll see that it actually, okay, it already exists because I didn't reset that, which is fine. So now we say go here. We say shell.php. Now here's where you got to get creative, because we know it's looking for 0. That's what it's looking for. So we say 0 equals, let's do something like ID, like it said before, or ls even, like it says before. Now you can see, look, I hit ls and look at that. We get a list of all of the files in the current directory. So now it's telling us here, find the flag. Okay, well, let's find the flag. So this is where you can say ls and ... right? Hit enter. Boom, there's the flag. So some of you may say, well, what was that? Well, all I did was say shell ls space period. That means list the directory behind the one that we currently are in, which is if we go present working directory, because we need to figure out what work directory we're in, var www html. So we know that var www has our flag in it, right? Because we were in this directory, it's not in here, and then we went back a directory and there it was. And the reason I covered URL encoding quickly is because if this doesn't work, you normally shouldn't be able to put spaces in your URLs. If you can't, then use URL encoding and you can put a space in there. So now all we got to do is say cat and go back one and say flag.txt and hit enter, and there's your flag. Boom. Very simple, very fun. All right. Last but not least, the mitigating SQL injections. I'm going to cover this quickly, but I'm not going to dive deep into this because of the fact that they only spend a little bit of time showing you, and then the skill assessment is the actual SQL injection. This is a SQL injection box. It's not really a whole lot about mitigating, but you do need to understand mitigation to at least be able to bypass some of it. So there's a couple things they're going to show you. So input sanitization. This is the first one. So there is no sanitization in this code here, but what you can see is as we go through, they're going to actually put sanitization. So what you can see, libraries provide multiple functions to achieve this. One such example is the MySQL real escape string. This function escapes characters such as commas and apostrophes, and quotes, so they don't hold any special meaning. So now, as you can see, when we run it and we put these, you can see when they put these quotes in there, it doesn't mean anything. It doesn't now, because if you remember at the beginning, we had to match the quotes, right? We had to match them perfectly. We had to make sure that they all matched, and we had balancing, as we called it, right? Well, this library, this MySQL real escape string library, allows you to say, hey, if somebody puts a quote or a quote or a comma in there, or apostrophe, I keep saying comma, but apostrophe, if we keep putting them in there, it doesn't mean anything. Take it as a string. Don't take it as to end the quotes for the query. So that's one thing. So sanitization, meaning get rid of the special characters that people are putting in there. Now, next one, input validation. This is validating what people are typing in. So for instance, I can say, hey, if you're supposed to be typing an email in here, only accept something if it has @whatever.com. If it doesn't, don't accept it, right? So that's input validation. That's very easy. So you can see here, same thing here, has to match a certain pattern. So here you can see it has to match A through Z, right? So it has to be a text. Otherwise it's going to say input valid, boom. Okay, then the next one, and then you can see here's the same thing with the match, and then you can see the code is modified to use the preg match function, which checks if the input matches the given pattern or not. The pattern is A through Z, which will only match strings containing letters and spaces. Pretty easy, right? Any other characters will result in termination of the script. So if you try to bypass it, boom, get rid of it. Now, some of you may say, and then you can see they tested it because they put 1, 2, 3, 4, and if you remember, they're only supposed to accept A through Z. And when they put 1, 2, 3, 4, we got nothing. Now, some of you may say, this seems really easy. Well, let's keep covering it, and then we'll talk about why it's not. So user privileges, this is, again, pretty simple. If you make everyone has the least amount of privilege that they need, then even if somebody accidentally does get a SQL injection, that account that is running that SQL database can't really do anything on the machine anyway, so it's not a big deal if they get it. I don't want to say it's not a big deal, they shouldn't get it, but it's not as big a deal. So just know that if you have the correct permission set, then it's much harder for somebody to take advantage of this, because as you can see, if you limit it to only allowing the accounts to read what they need, then there's not a chance that they're going to get the backend users and database and all that stuff that they're not supposed to read. For instance, never have root run your script or your database, excuse me. Now, web application firewall, this is pretty standard nowadays. So what it does is you put a web application firewall that also adds a layer of protection and actually stops certain packets coming in. So you can say, hey, if you see certain IPs, stop them. If you see certain queries, don't allow them to come through. If you see whatever, etc., etc. Web application firewall, you can put all kinds of rules in there to stop them before they ever hit the server. So now, and then parameterized queries. So this is basically saying, right here, the query is modified to contain 2 placeholders. So the query is already pre-made for you, and it's got parameters in there, right? See the parameters? Okay, so they're marked with a question mark where the username and password will be placed. We then bind the username and password to the query using this bind parameter. Boom, right? This will safely escape any quotes because it will only take these and put them in this location as a placeholder, meaning we can't say, oh, hey, comment this out, because even if you tried, we're going to have another one be put in place. So it's similar. Basically what they're saying is we're going to control where it can be placed in a query versus you manipulating the query itself. Again, so I talked about why these are not very easy to actually do. What I mean by that is these are easy to do relatively, meaning if you have 1 server, 2 servers, whatever. But when you're managing a lot of servers, it's very easy to stand something up and keep moving and totally just forget to put this validation in. And a lot of people always say, well, people shouldn't forget validation. Security is number 1, right? If you're a database admin or something like that, your job is not security. Your job is to get a database up and working. So your job, you're not even thinking at the time. You're thinking, I know how to get that up and working, and I got to get to the next thing. So I don't blame database admins or certain people for security issues in some of these databases. Do I wish everybody was 100% security minded? Of course, but that's just not realistic. So take it with what you will, but it's not as easy as you think, because people, it's just life. People get moving, people get going, and it's hard to make sure 100% that all your code is sanitized and proper and valid and all that. So let me know what you guys think. Hopefully this helps you guys. And then the next video I'm going to release this week, I'm going to get it out this week, is the skill assessment. And once that skill assessment's done, we will actually move on, and I will just put them all together, make one giant video out of it, so that way you guys can watch that as well. So let me know what you guys think. Hopefully you guys have a good one, and thank you. Yo, what's going on, guys? Welcome back. Today we are doing the skill assessment for the SQL injection fundamentals. As you can see, we've got it loaded up. We went ahead and went to the website. We are good to go. So the only tip they give us is assess the web application, use a variety of techniques to gain remote code execution, and find a flag. So we have to put together everything they gave us and find the flag, right? Sounds pretty simple, sounds pretty easy. Let's go ahead and get into it. Before we do, make sure you hit that like button, hit that sub button if you guys appreciate it, because I appreciate you guys. And also, this video is coming out today, but I will be posting, I'm not sure when, because I'll have to edit the video, but I will be posting all of the videos together if you want to walk through and do the entire thing. So it'll just be all the YouTube videos. I'll cut the intro off and put them all in one transition. So, all right, let's go ahead and get into it. So here we go. So first thing, we see the username, we see a password. 90% likely we have to try and bypass this, right? That's the first step. That's why I brought this up. You can see up here, if we go to right here, authentication bypass, so we're just going to follow along, right? It's that simple. Sometimes we're going to do what they said. So we can see here, go down to right here and try and put this in. Let's see what happens. All right, we say admin1 equals 1, password. Oh, it didn't work. Okay, let's see what we're looking at. So this is where SQL injection, a lot of people give up on this. And I'll tell you, don't give up. Try new things. So one thing, if we talked about it before in the past, is you have to do what's called quote balancing. So we have to have these quotes have to all match up. Well, typically we expect that it's going to give us an extra quote. It's going to add that quote on here for us. But what if it doesn't? What if we need to add it? Let's try. Nope. Okay. So what else do we think? So we know that we are on the right ballpark, right? We at least know that. At least we can guess that. So what if we just have to do it properly? What if we say, let's go ahead and do that again. So what if it's very specific about its there we go. What if it's very specific about its payload, right? So we say admin, or maybe it needs to be exactly the way they want it, right? Maybe we need to comment it the rest out so it doesn't keep building it out, right? What if we close the quotes and then comment the rest out? Now we don't have to worry about quote balancing, at least in this case, because we know there's a quote here and we know that we're ending the quote and then putting comments. We're saying, hey, that's all we want, right? So mess with the payload a little bit. Oh, look at that, we're in. So just like that, we're in. Now, some of you may say, okay, cool, you got the admin account, but we need to get on the actual machine itself, and you are correct. So we have the search function. Well, if they had SQL injection in the username and password, they probably have SQL injection in the search function. So what's the best way we can do the search function? If you remember, we can search for anything, right? And you can see I already did this. We'll do union select. If you remember, you do this, we got the comment, then we do union, and we're going to select, and we're going to select one. And the point of this is we're trying to see how many columns does it have that we have to match where we can actually put the payload. Because when we search, you'll see, oh, the use select statement has a different number of columns. So that wouldn't return anything even if we did it. So let's do it again. Let's go to 2. Nothing, doesn't have the same amount of columns. Let's go to 3. Doesn't have the same amount of columns. Let's go to 4. Doesn't have the same amount of columns, and you can guess it. If we go to 5, look at that. It prints out the information that we've put it, which is 1, 2, 3, 4, 5, right? So we've said union, select, and then we put 1, 2, 3, 4, 5 so that we can see it like this, because we have to figure out if we inject our payload, where's it going to print out, right? Well, we know if we'd have put it in the first column, we wouldn't see it. It's not here. It doesn't exist. But if we put it in 2, 3, 4, or 5, we can actually gain something from it. So right off the bat, let's go ahead and do that. Let's say we'll do 5, but maybe we'll just do 2. We'll put it in 2. So in 2, we'll just say, like right off the bat, we'll just say user. Who are we actually logged in as? Let's see if it works. Oh, look at that. We're root. So right off the bat, we are root, which means, okay, we're in pretty good case. Now, if you read the Try Hack Me module and you go through, the next step it says is check permissions and all of that stuff. You guys can feel free to do that. If you get root on a machine, or if you're using root, yes, I understand that I'll say this, I understand that it doesn't always mean that you're going to get whatever you want. But I'm not going to go through and check the permissions. If I have root, I'm going to try and go to the next step, which is we're going to try and manipulate files and things like that on here. So first thing we're going to do, add that payload back, right? We got to keep editing it. So I want to keep using this 2 field. You can use whatever field you feel confident about. You can use, as you can see, 2, 3, 4, 5, whatever field you want. I'm going to keep using 2. And what we're going to do now is we're actually going to start pulling what tables we need, right? Because if you remember, we can go back to it here. Let me pull it back up. Right here, if we go back to, you can see, where was it? I think it was the last one we just did. Database enumeration right here. We need to start pulling files from it, right? So we need to see, we've got this, the union statement, but what is the schema name? Let's go straight for that, right? We don't have to use the, so we'll do this, union, so we've got the union select. We'll just get rid of all this, paste that in there, and we're going to ask the schemata information for the, and you can see I have D in here, and you got to put that comma in there. All right, so we're going to ask it for the schema names. All right, looks like it has a different number of columns, probably because I didn't edit it, right? So that only has 4. We have 5. So make sure you edit it before you do it. So 1, 2, 3, 4, and 5. Did I put a period? Hopefully I didn't. I might have put a period in there. Okay. So different number of columns there, it says as well. So we have union select 1, schema name is 2, then 3, then 4, then comma 5. Okay, I think I put a period in the first one, if I'm being honest, which if I did, I apologize. So, all right. Should be good. There we go. So now we can see, and if we look at it, pretty well is exactly like the box we've already done, which is we've got the information, the MySQL performance, we have ill freight and backup. Now, if we read the question, let's see if there's use a variety of, okay, so it doesn't say anything about where it might be, but ill freight and then backup. I'll say backup usually, don't quote me on this, but usually the backups have different things in them. But so we can keep enumerating this, but one of the things we want to look at is, do we have access to write files, right? So you can see we could sit here and we could enumerate all the databases, all that stuff, but if we can just get on the machine, we can bypass all that, right? At least that's my assumption, right? So what we can do is we can go back, and I keep going back. You guys don't have to do this. I do this so that you guys can see that where I'm getting the information, because a lot of times people ask me like, how would you just know that? How would you just know that, right? Well, when you're doing boxes like this, they're kind of just telling you, so you don't have to just know it, right? They're giving it to you. So we can go through here and look at this. We can say, not this one. I don't care. I know that we have secure file privileges because we're on root. Now, I don't always assume that, but so we can do this. We can say, find the exact one they gave us. Here we go. The select file, right? We can go here. We can go here, and we can say use that union, right? So, whoops. We'll use the union select 5, right? Take out the 2 and say and I know I've got to edit this because it already kind of put it all in there for me. So we want to say select, we'll get rid of the second select. So we want to say select, and then we're going to say file written successfully. That's just a test saying, hey, if this works, it'll say file written successfully, right? And then we want to say get rid of into out file, because that next should be our 3, 4, 5, whatever, and then we'll just add those in ourselves. Okay, so now 3, 4, 5, and what we're going to do is say after the 3, 4, 5 is simply say into, and by the way, I'm not putting this in caps, it's already doing it, so if you're trying to figure out why I'm doing it in caps, it's already doing it. And then the out file will just be var www html, just like before, not html, HTML, just like they did. And then if you look, we need this dashboard because that's where our actual file is. That's where we have access to, so dashboard. And then you'll just say proof.txt because you're gonna put the proof in here, right? And then see if we've got our comments already in there. Let's make sure we have our quotes in there. Looks good. We hit enter. We get nothing back. That's good. Typically that's good, right? So we're gonna now say copy this and go here, say paste, and we should see proof.txt if we can write to files. And look at that, we can write to files. So what's that mean? It means we can get a shell already, right? We don't have to do anything crazy. We can actually get a shell. So we've got our proof.txt here, and that's the same thing that they had us do earlier. So now all we got to do is get our shell. And if you remember, we'll go back to it. And I know I keep going back and forth, but it's just easy to show you. If we can write a file, we can just do this PHP system request. Look at this, copy this exact thing. We just have to change the columns here because they've added those columns. We're going to keep them at 1, 2, 3, 4, so that way you guys can see it. So what we'll do, go through here. There we go. And we're going to make sure we change these to 4 and 5. So 5, I don't want spaces in there. Actually, we will keep spaces in there just to keep it clean. So what we'll do, just to keep it clean, we'll keep spaces in there. But we do have to add that 5th column. If you don't add a 5th column, then it's not going to work. Okay, should be good. And we named it shell.php. Looks like can't write to file var HTML. That's because we're not, that's the wrong path, right? If you remember, we need an HTML dashboard. Shell.php. The select statement has a different number of columns. Okay, I didn't change that one. I'm all over the place right now. No, I'm just doing it fast. So we need to change dashboard, shell.php, and then we got to make sure we add that 5th column again. If we don't add that 5th column, it doesn't work. Okay, so there we go. Okay, we get nothing back. That's what we should get. Now when we go here to dashboard and we say shell.php, right? What we should get is we should actually put something in where the 0 is. If you remember that 0, it's requesting 0. If you guys don't remember that, go back to the last video. The last video is where I did it. And then we're just going to say, hey, what do we want to request? And we can change it to whatever we want. You can see that if we go to here and you look, request 0, all we have to do is say blank 0 equals whatever. And we can make it anything we want. So we're going to say here, shell.php, and then we can say 0 equals, and in this case, we'll just say ls for now, but it doesn't really matter. Okay, and you can see we have dashboard, proof.txt, which is the one that we just did. So now we have a working shell that we can manipulate and mess with. And the question is, and we're already root, so find a flag in the root directory. So we can just say ls, ls in the root directory. There we go. We have flag ca whatever this is. Copy that, and we can say cat that flag, and it didn't work. Why didn't it work? Probably because of the space and this underscore. So we have to URL encode it. Let's see if this cheat sheet has it on here so I don't have to go through. Nope. Okay, it doesn't have it on there. That's fine. What we'll do is we'll take this right here, copy it, go to, we'll just do it in here, Cyber Chef, and you can do it, you can just look it up. This one's only a couple, so it's not very much, but I'll show you. So we'll put the input, right? And then we'll say URL encode. Here's our output. And let's take a look. So now we go here, and instead of the PHP equaling that, we'll have it equal that, and we should be good. And maybe we got it wrong because we're getting nothing here. Let's take a look. Okay, flag ca Oh, it didn't even change. So you can put spaces in here. Interesting. Okay, I wonder why we can't cat it. So we'll have to kind of mess with it some more and see why we can't cat it. But we could also, instead of doing cat, we could load the file itself. Maybe it's a weird file. I'm not sure. Let's see. Maybe we don't have permissions to it, but we're root, so we should. So let's go ahead and try a different technique. Not sure why catting it's not working. Let's go back. Let's do this. Let's see if we can actually cat the rest of the files in there. So if we say, oh, I can tell you why I can't cat it. Why is nobody correcting me here? You guys are letting me slide here. It's because I'm in the wrong directory. There is no file named that, you clown. What am I doing? There we go. What am I doing? This is what happens when you're flying through these things. There you go. That was an easy fix. And then there you go. Pretty easy. So, oh, incorrect answer. Maybe it's not pretty easy. they're saying this isn't the right one. Assess the web application, submit the contents of the flag as your answer. Maybe it's that space at the end. There it was. It's a space at the end. So very easy, very fun. I like the module. I like the SQL injection that they taught. It's a very fun box. Realistically, you can knock this out pretty fast. The assessment at the end, very nice. I like it. Pretty easy, pretty simple. But I want to see what you guys think. Let me know in the comments below. Is this something that you guys enjoy? Excuse me. Is this something you guys enjoy doing? Is this something that you struggle with? What do you guys think about SQL injection? Because I see people all the time still on SQL injection saying, I don't understand how this is still a thing, and I don't understand, et cetera, et cetera. I want to know your guys' opinion on it, because I have my opinions, but I want to save those. You can hop in the Discord, we can chat about it, but I'm not going to just go on a rant about SQL injection. So let me know what you guys think. Hopefully this helped you guys, and put a like on that video. It helps me out a ton. Thank you guys. Have a great day.